Hello, my name is David Jong, and we'll be working on number 10. So what number 10 asks us is to find the velocity vector at the time when the particle's horizontal position is at x equals to 25. So how do we do that? So we know that the horizontal position of x is at 25, right? So we know that x of t equals to 25. We'll make that equal to x of t. So it's 25 equals to 5t plus 3 sine t. And we go into our calculator, and if we make one of the lines 25 and one of the lines 5t plus 3 sine t, and we graph it, we can find the intersecting point to find that t is equal to 5.4457. And then, so what do we need to do to find the velocity vector? We need to find dx over dt, and then dy over dt. And then we plug in the 5.4457 into these equations right here. So to find the derivative of x of t, or dx over dt, let's first find the derivative of the equation right there. So the derivative of 5t plus 3 sine of t is 5, or let's write this out first. It's the 5 plus 3 cosine of t. And when we plug in 5.4457 on our calculator, so 5 plus 3 cosine of 5.4457 on our calculator, we can find that the answer is 7.0079. And then now it's time for the y equation. So if we find the derivative, or first, before we do anything, we need to factor out the y equation so we can get an easier derivative, which is 8 cosine of t minus t plus t cosine of t. And then when we find the derivative of that, we can see that it is 0 plus 8 sine of t, subtracted by 1, plus, parentheses, t sine of t. And then if we simplify that, it is 8 sine of t subtracted by t sine of t subtracted by 1. If we plug in 5.4457 into that, we can find out that the answer is 8 sine of 5.4457 minus 5.4457 sine 5.4457 subtracted by 1 is negative 2.8977. So our velocity vector is 7.0079 and negative 2.8977. Thank you.